So today we will consider the decay of current in the series RL circuit. So let us take the case of a series RL circuit where resistance and inductor are connected in series. If it is broken at the instant, broken means it is disconnected. Okay, battery is disconnected at the instant the inductor opposes the decrease in current. Okay, because of the electromagnetic induction, the inductor will oppose the decrease in current. The current does not fall to zero instantly, but decreases in short intervals. Okay, so current in the circuit will not suddenly fall to zero, but instead of that, the current decreases in a short interval of time. So that leads to the transient phenomena. So let us consider a series RL circuit with a switch as in this particular figure. Okay, so where R and L are connected in series, initially the switch is at position A where a battery is connected in the circuit, which leads to the growth of current, and finally current reaches to the maximum steady value equal to I0. Let us take I0 is the maximum steady current that flows through the circuit after certain time if battery is connected in the circuit. So when switch is at position A, the current grows in the circuit and then becomes steady. When battery is connected, when switch is connected to position A, the current in the circuit increases and it becomes maximum. And let us take it as I0. I0 is the maximum current, which is a steady current flowing through the circuit when battery is connected. Suppose switch is moved to position B suddenly. Suppose battery is disconnected suddenly. If a switch is moved from position A to position B, only this part of the circuit is closed now. Okay, so R and L are connected in series and they are connected by means of certain conductor. So then what happens? Current in the circuit start to decrease. If suddenly switch is connected from position A to position B, current start to decrease. And that decrease of current is called as decay of current. We call it as decay of current. Okay. The decay of current is opposed by the inductor. Basically, this decrease of current is going to take place slowly because of the electromagnetic induction, because inductor will oppose the variation in current. Basically, decrease in current or increase in current, it will oppose. So here current is decreasing and inductor will oppose that. So how does the current decreases? What is the expression for current as a function of time we have to obtain? Okay, we have to obtain the expression for current. That is our aim. So let us apply the KVL and let us simplify. So this is the circuit where switch is connected to position B. This part of the circuit is active now. Okay, so current is flowing in this part of the circuit and it is basically decreasing. It is decreasing from the maximum current I0. I0 in the next decrease October. Let us apply the KVL to this loop. Only two components are there, resistance and an inductor. So therefore, the KVL gives you voltage across the resistor plus voltage across the inductor should be equal to 0. Okay, so I into R, voltage across the resistor is IR. Voltage across the inductor is basically minus L into di by dt. Here I is decreasing, current is decreasing, that's why minus into minus it becomes plus. Okay, di by dt is negative. Basically voltage across the inductor is minus L into di by dt. Since di by dt is again negative, that's why the voltage, effective voltage across the inductor according to KVL becomes equal to plus L into di by dt. And IR is the voltage across the resistor. This is a first order differential equation in I. Okay, current is variable, it is decreasing, and time is variable. R and L are constants. So this is a first order differential equation. Do the solution, you try to find the solution for this equation by separating the variable, etc. So then rearrange, you will get L into di by dt is equal to minus IR. Okay, then rearrange, you take the terms containing I on the one side, I on one side and other terms on the other side. You will get di by I is equal to minus R by L into dt. Okay, I will take L to the other side. So you will get a di by I is equal to minus R by L into dt. So separation of variable is done. So here this is containing the terms containing I. This is constant term. R by L is a constant term into the variable dt. Let us integrate it. To solve the equation, we have to integrate this. So we have got the separated variables. Separation of variable is done, and that gives you
recording in progress. Recording in progress.
Okay. So we have the separation of variable. So we have got di by I is equal to minus R by L into dt. Okay. So then integrate this with respect to I, that will give you ln of I. Okay. So integration of 1 by I is ln of I, that is equal to minus R by L into t plus some integration constant C. So integration of 1 by I is ln of I. Okay. Then integration of dt is simply t. So you have got the solution for the equation as ln of I is equal to minus R by L into t plus some integration constant C. To find the integration constant, what you have to do, you put the initial conditions. Okay. To find the integration constant, put the initial conditions. That is, when t equal to 0, the initial current was I naught. Okay. So when t equal to 0, when before putting the switch at position B, the initial current was maximum, that is I naught, which is the maximum steady current when the circuit is switched to position B. Okay. So therefore, you put t equal to 0 and put I equal to I naught. At t equal to 0, I equal to I naught. So therefore, C will be equal to ln of I naught. Because this term becomes 0, C will become ln of I naught. So which is the integration constant C. So substitute here, substitute for C and simplify it further. So you will get ln of I is equal to minus R by L into T plus ln of I naught. So you put value of C as ln of I naught and collect the terms containing ln of I naught on one side. You will get a ln of I minus ln of I naught, which is equal to minus R by L into T. Okay. So you take ln of I naught to the other side. So this is of the form ln of m minus ln of m. So that will be ln of m by m. So this will be ln of I by I naught, which is equal to minus R by L into T. So you need the expression for I. You convert this logarithmic equation into exponential equation. You know that the ln of some m is equal to x. It means that m will be equal to e to the power x. So therefore, this will give you I is equal to I naught into exponential to the power minus R by L into T. So this is how we can convert the logarithmic equation into exponential equation. So this expression gives you the decreasing current in the series RL circuit. So this gives you the decay of current in series RL circuit. So suppose if you put T is equal to L by R. So at that time, T is equal to L by R, what will happen? This equation becomes I is equal to I naught into e to the power minus 1. So R by L into L by R. L gets cancelled, R gets cancelled, you will get 1 here. The power will be 1. So e to the power minus 1 is equal to 0.37. Therefore, at T is equal to L by R, you will get I is equal to 0.37 times of that I naught. Okay, where I naught is the maximum current. So this ratio L by R is called as time constant of the RL circuit. So which is defined as the time during which the current decays to 0.37 times that of the maximum current in the circuit. Okay, so current falls to 0.37 times. The value of L by R decides the rate of decay of current in RL circuit. So if L by R ratio is larger, then it takes more time to observe the decay of current. Okay, because in that particular time, current falls to 37% of the maximum current. Okay, so 37% of the maximum current at T is equal to L by R. That's why the value of L and value of R decides how fast decay of current takes place. If L by R ratio is very small, if time constant is very small, the decay of current is going to be very fast. Suddenly, current decreases. If L by R ratio is large, then current will decrease slowly. Okay, so rate of decay of current will be slower. That's why the value of L by R decides the rate of decay of current in RL circuit. Okay, so next you observe the decay of current that is represented graphically by using this particular graph. So current decreases with time. Okay, exponentially the current decreases. It will decrease from I0. Maximum current is I0. Then it decreases exponentially. It will become 0 after certain time. And at T is equal to L by R. So there should be L by R. At T is equal to L by R, the current falls to 0.37 times of I0. Okay. So ಇಷ್ಟು ಟೈಮಲ್ಲಿ ಕರೆಂಟ್ ಏನಾಗ್ತದೆ 0.37 times I0 ಆಗಿರ್ತದೆ. I0 ಇಂದ ಇಲ್ಲಿಗೆ ಬಂದಿರ್ತದೆ ಅಂತ. Okay. So current will decrease exponentially. This is the graph representing the variation of current with time in decay of current case in the series RL circuit. So during the growth of current, so if you collect both growth of current and decay of current, during the growth of current, when a battery is connected, the flow of charges due to EMF stores the energy in the inductor in the form of magnetic field. So when battery is connected to the series RL circuit, the magnetic energy start to store in the inductor. Inductor ಒಳಗೆ magnetic energy store ಆಗಲಿ start ಆಗ್ತದೆ. Okay. The maximum energy stored in the inductor when current reaches steady state is given by half L I0 square, where I0 is the maximum current. So when the current becomes steady, the maximum energy will be stored in the inductor, and that maximum energy is equal to half L I0 square. That is the expression for maximum energy stored in the inductor during the growth of the current. So when decay of current takes place, when battery is suddenly disconnected, the magnetic energy in the inductor start to decrease. The decrease in energy is due to the dissipation of energy in the resistor in the form of heat. Okay, so how does energy decreases? The magnetic energy stored in the inductor will be converted into heat energy or the radiation energy. Okay, so because of that, the decrease in energy is going to take place when there is a decay of current. Current decay agide antandre energy decrease ಆಗ್ತಿದೆ ಅಂತ ಅರ್ಥ. Okay, because the energy is given by half L I0 square, where current decreases, the total energy also going to decrease. The sudden breaking of RL circuit provides high rate of fall of current. Suppose if you disconnect the battery suddenly, it gives you high rate of fall of current. There will be sudden fall of current, and consequently it induces very high voltage. Okay, electromagnetic induction process will take place, and that will create a very high induced voltage, and this process is called as inductive kick. This is called as inductive kick, where high voltage is produced because of the sudden disconnection of the battery in the series RL circuit. It is called as inductive kick. So this phenomena is used in automobile ignition system and to produce the high voltage in the tube of the TV receiver. So whenever you need very